Welcome to my channel. Tonight, we begin a journey that does not require us to move an inch from where we are resting, but one that will take us miles above the ground, into the vast, silent, and protective embrace of the sky. Take a moment to settle into your space, feel the weight of your body against the bed, let your shoulders drop, and breathe, slowly, naturally. We often think of the air around us as empty space, as nothingness, but in reality, we are living at the bottom of a magnificent, invisible ocean of gases, a vast and gently swaying sea we call the atmosphere. Unlike the ocean of water, we do not need a snorkel to breathe in this one, though it is the grand stage upon which all the drama of weather plays out. Imagine, if you will, that the atmosphere is about as thick, proportionally, as the skin on an apple. Most of it hugs the earth in a tight, shallow band, holding us close, keeping us safe. The atmosphere is made of layers, each one with its own personality, like the strata in a cake. Let us begin our ascent through these layers, drifting upward, starting in our home layer, the troposphere. The troposphere is the lowest layer, the realm where all the weather we care about actually happens. It is where clouds form, where rain falls, and where the wind gets up to all sorts of mischief. It stretches up to about 7 miles high on average, though it can be taller near the equator and shorter near the poles. In this layer, the air is dense and life-giving. It is made mostly of nitrogen, which makes up about 78% of the mix. Oxygen takes up around 21%, the spark of life for every breath you take. The rest is a cocktail of trace gases like argon, carbon dioxide, and a dash of water vapor. As we drift higher, the air becomes thinner, quieter. We move into the stratosphere. Here, the air is calm and steady. This is where you will find the ozone layer, Earth's very own pair of sunglasses, shielding us from the sun's more mischievous ultraviolet rays. There is a profound stillness here, far above the storms and the turbulence of the world below. Continuing our silent climb, we pass through the mesosphere. It is a place of cold mystery, but also a place of protection. This is where meteors, those rocky visitors from space, meet the resistance of our air and burn up in bright, fleeting streaks. What we see as a shooting star is actually our atmosphere standing guard, protecting the surface while the world sleeps. Higher still, we enter the thermosphere, a realm of auroras and satellites. Here, temperatures can reach thousands of degrees, yet it would not feel hot to your skin because the air is far too thin to conduct heat. It is a ghost-like realm, where the northern and southern lights dance in curtains of green and violet, fueled by the solar wind. At the very edge, merging with the infinite blackness of space, is the exosphere. This is the whispery fringe of our atmosphere, where molecules are few and far between, occasionally drifting off into the cosmic beyond. It is the transition from our home to the universe. But for tonight, let us return our thoughts to the troposphere, our cozy home layer. The air here behaves like a fluid, just like water. It flows, it swirls, it tumbles, and it reacts to changes in temperature and pressure. Warm air tends to rise because it is less dense, while cold air sinks because it is heavier. This simple principle, warm air up, cold air down, is the heartbeat of all weather. When the sun shines on the earth, it does not heat everything evenly. The equator gets a solar spotlight, while the poles receive a dimmer glow. Because nature absolutely loves balance, the atmosphere is always trying to even things out. It is a self-organizing masterpiece of physics, driven by gravity and the golden rule that energy tends to spread out. Imagine the air pressing gently upon you right now. It has weight, about 14 pounds per square inch at sea level. It is like having a small, warm cat gently pressing on every inch of your body at once, a constant, rhythmic connection to the sky. High-pressure systems bring stability and clarity, while low-pressure systems bring movement and growth. As the Earth spins beneath this ocean of air, at over 1,000 miles per hour at the equator, the movement of air gets twisted and turned. This is the Coriolis effect, making winds curve as they travel, a delightful scientific quirk that sounds like magic but is simply physics doing its thing. The atmosphere never truly sleeps. Even on the calmest, cloudless night, there are quiet currents of air slipping past your window, subtle changes in humidity, invisible dances of temperature. It is a system that is vibrantly alive, yet deeply peaceful. Everything you see in the sky, every gust of wind, every scuttling cloud, is part of a grand planetary ballet. It is an ancient, invisible choreography, powered by the distant touch of the sun and stirred by the constant pull of gravity. Tonight, as you drift closer to rest, remember that you are tucked beneath miles of this protective air. You are safe within the layers of this invisible ocean. While the sky continues its slow, majestic dance above your head. The air is still, the pressure is balanced, and the world is quiet. The great conductor of the movement in the sky, the whisper of the winds, and the drifting of the clouds, is the sun. Even as you rest right now, no matter how still the air outside your window may seem, the atmosphere is functioning as a massive, tireless heat engine, working day and night to distribute energy across our planet. The story of every breeze begins with a photon. A tiny packet of light traveling 93 million miles through the cold vacuum of space, only to be caught by the thin, protective veil of our atmosphere. When these rays reach the Earth, they do not touch every corner with the same intensity. Because our world is a sphere, the sun's warmth strikes the equator directly, concentrated and powerful, while at the poles, the same amount of light is spread thin over a much larger area, leaning away into the shadows. This fundamental imbalance, this simple difference in temperature, is what sets the entire world in motion. Nature, in its infinite wisdom, abhors a vacuum and dislikes extremes. It is always seeking equilibrium, always trying to bridge the gap between the heat of the tropics and the chill of the Arctic. Imagine the surface of the Earth breathing. As the dark soil of a field or the deep blue of the ocean absorbs the sun's energy, it warms the air directly touching it. In the world of physics, warmth is movement. The molecules in the air begin to dance faster, they push away from one another, and the air becomes lighter, less dense. Like an invisible hot air balloon, this warmed parcel of sky begins to rise, drifting upward through the cooler layers above. This is the process of convection, a slow, silent elevator ride for the atmosphere. But as this warm air ascends, it leaves behind a space, a pocket of lower pressure. And nature cannot leave that space empty. From somewhere nearby, where the air is cooler and heavier, a new current begins to flow in to fill the gap. This movement, this simple act of one air mass replacing another, is the birth of the wind. It might be a gentle sigh that barely stirs a leaf, or a powerful jet stream high above, but it all starts with the sun's touch. The Earth is not just a passive recipient of this heat. It is a complex landscape of textures. Oceans, which cover most of our world, are slow to change. They act as a massive thermal reservoir, absorbing heat slowly during the day and releasing it with a long, lingering exhale throughout the night. Land, however, is impatient. It heats up quickly under the afternoon sun and cools just as fast when the stars come out. This difference between land and sea creates the coastal breezes many of us find so soothing. During the day, the land warms and pulls the cool sea air toward the shore. At night, the process reverses, as the land chills and the ocean remains warm, sending a land breeze back out toward the waves. It is a rhythmic, hypnotic exchange. The earth breathing in and out with the rising and setting of the sun. If the earth stood still, the air would simply move in straight lines from the equator to the poles. But our world is spinning, rotating beneath the atmosphere at incredible speeds. This rotation introduces a beautiful complexity called the Coriolis effect. It gently nudges the moving air, causing it to curve and swirl. In the northern hemisphere, the winds are coaxed to the right, in the southern, to the left. This is why storms spin, why the great trade winds blow with such reliable persistence, and why the weather systems we see on satellite maps look like swirling galaxies of white vapor. Think of the energy involved in this process. The sun delivers more energy to the earth in a single hour than all of humanity uses in an entire year. Much of that energy goes into evaporating water, lifting trillions of tons of moisture into the sky. When that water vapor eventually cools and turns back into liquid, it releases that stored solar energy back into the air. This latent heat is the hidden fuel for the world's great storms. It is the sun's energy, captured in the ocean, carried by the wind, and released in the clouds. As you settle deeper into your rest, visualize this grand machinery at work. Far above you, even in the darkness of night, the atmosphere is still busy. High-altitude winds are rushing across continents, carrying the warmth of yesterday toward the chill of tomorrow. The sun may be hidden on the other side of the world, but its influence is felt in every molecule of air that surrounds you. The engine of the world is silent, but it is powerful. It is a system of perfect logic, where heat seeks cold, and pressure seeks balance. It is a reminder that everything is connected, that the light from a distant star can create the soft breeze that cools your skin. The air is settling now. The convection currents are slowing as the ground loses its daytime warmth. The atmosphere is finding a temporary peace, moment of stillness before the sun returns to start the engine once again. Feel the stability of the air around you. Let the thought of this vast, solar-powered dance lull you into a state of calm. The world is in balance, the engine is humming quietly in the background, and all is as it should be. When you look up at the sky and see those white, fluffy masses drifting lazily across the blue, they seem to possess no weight at all. They appear as if they are defying gravity, floating like tufts of dandelion seed on a summer breeze. But contrary to their delicate appearance, a single, medium-sized cumulus cloud can weigh about 500,000 kilograms. That is the equivalent of 80 adult elephants hanging suspended above your head. It is a staggering thought, that such a massive weight can stay aloft without falling to the earth in a single, crashing moment. The secret to this architectural marvel of the sky lies in the invisible support of the air itself. A cloud is not a solid object, but a collection of billions upon billions of microscopic water droplets or ice crystals. These droplets are so small, so incredibly light, that the gentle upward pressure of rising warm air, the convection currents we discussed before, is enough to keep them suspended. They are caught in a delicate balance between the pull of gravity and the persistent nudge of the atmosphere. The birth of a cloud is a quiet, microscopic miracle. It begins with water vapor, an invisible gas that is always present in the air around us. As warm air rises and expands, it begins to cool. Cooler air cannot hold as much water vapor as warm air. And so, the moisture must find a way to return to its liquid state. But water vapor cannot simply turn into a droplet on its own in the empty sky, it needs a surface to hold on to. This is where the invisible dust of the world plays its part. Tiny particles of salt from sea spray, microscopic bits of dust from the soil, even smoke or pollen, act as cloud condensation nuclei. These invisible specks are the seeds of the sky. Water vapor clings to these particles, huddling together until a tiny droplet is formed. When enough of these droplets gather in one place, a cloud becomes visible to our eyes. Think of the sheer scale of this process. To make a single raindrop, it takes about 1 million of these tiny cloud droplets colliding and merging together. Until then, the cloud remains a misty ghost, a floating reservoir of potential energy. There is a profound variety in these celestial structures. The cumulus clouds, those classic, puffy cotton balls, are the signs of fair weather and active convection. They have flat bases where the air has cooled just enough for condensation to begin, and towering tops where the air is still pushing upward. Then there are the stratus clouds, the gray, featureless blankets that cover the sky like a soft quilt, bringing a sense of quiet and introspection to a rainy afternoon. Higher up, where the air is freezing, we find the cirrus clouds. These are not made of water droplets, but of delicate ice crystals. They look like wisps of hair or the strokes of a paintbrush across the high atmosphere. Because they are so high, they often catch the light of the sun long after it has set for us on the ground, glowing in hues of pink and gold against the darkening blue. And then, there are the cumulonimbus, the kings of the sky. These clouds can stretch from the bottom of the troposphere all the way to its ceiling, flattened at the top by high-altitude winds into the shape of an anvil. They are massive factories of energy, holding millions of tons of water and churning with powerful internal winds. Even these giants, for all their power and weight, are held up by the same principles of air pressure and temperature. Imagine yourself drifting among these cotton castles. The air inside a cloud is cool and damp, a world of white mist where the sunlight is scattered in every direction. It is a place of constant change. Clouds are never still, they are always evaporating at the edges and growing at the center. They are living entities of the atmosphere, constantly reshaping themselves in response to the invisible currents of the wind. The weight of a cloud is a reminder of the hidden strength of nature. We walk beneath these 500,000-kilogram giants every day without a second thought, trusting in the invisible laws of physics to keep the sky where it belongs. It is a testament to the density and power of the air we breathe. As you lie still, imagine the moisture in the air around you. It is invisible now, but it carries the potential for 1,000 clouds. The water you see in a cloud today might have been part of a distant ocean only a week ago, or perhaps it was locked in a polar ice cap for 1,000 years before being set free by the sun. The sky is a great recycler, moving water across the globe in a silent, heavy, and beautiful parade. The atmosphere is a master builder, using nothing but light, dust, and water to create landscapes more grand than any mountain range on earth. These Pamuk Kalalair, these cotton castles, are temporary monuments to the balance of our world. Feel the quiet stability of the room, while high above, the weight of the clouds continues to shift and flow. The sky is heavy with beauty, but the air is strong enough to hold it. Everything is supported, everything is in its place. Let your thoughts become like those microscopic droplets, light, suspended, and calm. Drift along with the invisible currents of the night. The clouds are watching over the world, silent and majestic, as they continue their endless journey across the horizon. We have spent time visualizing those massive cotton castles, those tons of clouds suspended in the blue, holding their breath above the world. Now, I invite you to feel the invisible hands that move those castles, the force that drags them across continents and over vast oceans. The wind is the restless breath of the atmosphere. To us, it might only be a cool sensation on the skin or the rhythmic rustle of leaves outside a window. But in the grand design of the earth, wind is the purest expression of nature's struggle for balance. Imagine, if you can, the air around you not as a void, but as a fluid, constantly seeking its own level. Every breeze you have ever felt is simply the result of an imbalance, a conversation between high pressure and low pressure. Nature abhors a difference that stays still, where the air is dense and heavy, piled high by the cooling of the earth or the sinking of currents. We find high pressure. It is a state of abundance, of weight, and it wants to share that weight with the world. Somewhere else, perhaps where the sun has warmed the ground and sent the air spiraling upward, there is a void, a pocket of low pressure. It is light, airy, and empty, like water flowing down a hill. The heavy air from the high-pressure zone feels the pull toward the emptiness. It begins to move. It flows. And that flow, that invisible migration of molecules, is what we call the wind. The greater the difference between these two zones, the steeper the invisible hill, and the faster the wind will rush to close the gap. Meteorologists look at these differences through lines called isobars, silent, curving signatures on a map that connect points of equal pressure. When those lines are packed tightly together, like the rings of a tree, the wind is fierce and determined. When they are spread wide apart, the air is calm, barely a whisper, a gentle sigh of the planet at rest. As you lie there, think of the wind as a great healer. It is the Earth's way of evening out its temperature. It takes the surplus heat of the tropics and carries it toward the shivering poles. It takes the moisture of the sea and delivers it to the thirsty land. Without the wind, our world would be a place of impossible extremes, too hot to endure in some places, too cold to survive in others. The wind is the great distributor, the circulation system of a living planet. But the wind does not travel in a straight line. Because our Earth is a spinning sphere, the wind is subject to the Coriolis effect, that subtle, phantom force that nudges the air as it travels. It turns the wind into a dancer, making it swirl and curve. In the northern hemisphere, the air is coaxed to the right, creating the clockwise rotation of high-pressure systems. In the southern hemisphere, it is pulled to the left. This rotation gives the atmosphere its texture, its eddies, and its grand, sweeping patterns. High above our heads, far beyond the reach of the tallest trees, there are the jet streams. These are the great rivers of the sky, narrow bands of incredibly fast-moving air that race around the globe. They are the borders between cold polar air and warm tropical air. They flow at speeds that would leave a hurricane in the dust, yet we barely feel them on the ground. Except when they dip down to bring us a sudden change in season. They are the master choreographers of our weekly weather, guiding storms and steering the clear blue skies. Closer to the earth, the wind is shaped by the land it touches. It learns the contours of the mountains, flowing over peaks and pouring down into valleys like a silent waterfall of air. These are the anabatic and katabatic winds. Local whispers born of the mountain's shadow and the valley's warmth. Even the smallest hill creates a ripple in the flow, a tiny turbulence that adds to the complexity of the atmosphere's song. There is a deep peace in understanding that the wind is never random. Every gust that rattles a windowpane or cools your brow has a destination and a reason. It is fulfilling a physical law, chasing a balance that it will never truly find. Because the sun is always rising somewhere, starting the cycle all over again. The wind also carries the history of the world. It carries the scent of pine forests from 1,000 miles away, the salt of an ocean you have never seen, and the dust of deserts ancient and vast. To breathe the wind is to connect with the entire surface of the earth. It is a global exchange, a shared breath between all living things. As the night deepens, imagine the winds around the world beginning to soften. Near the ground, as the sun's energy fades and the earth cools, the air becomes more stable. The turbulent mixing of the day gives way to a laminar flow, a smooth, layered movement that is quiet and predictable. The atmosphere is settling into its nocturnal rhythm. The high-pressure systems are like heavy, comforting blankets of air pressing down upon the landscape, bringing clear skies and stillness. The low-pressure systems are like gentle vacuums, lifting the spirit of the air upward toward the stars. Between them, the wind continues its work, but more quietly now, as if it too is weary from its journey across the plains. Think of your own breath. It is a small version of the world's wind. A rhythmic movement of pressure, in and out, seeking balance within your own body. As you breathe, you are part of the atmospheric engine, a tiny participant in the grand circulation of the planet. The air outside is moving, but it is moving with purpose. It is moving to make the world right, to bridge the gaps, to heal the differences in temperature. It is a system of profound logic and beauty. The pressure is equalizing, the lines on the map are smoothing out. The whispers are becoming silence. The wind is drifting, and so are you. Everything is in motion, yet everything is still. The balance has been found for tonight. The atmosphere is at peace. We have just imagined those invisible hands of the wind, gently dragging the heavy cotton castles of clouds from one continent to another. Now, let us focus on the most fertile moment of this journey, the moment when the sky reaches down to touch the earth. Rain. Rain is not merely a weather event, it is an eternal dance of recycling that the atmosphere has been performing for billions of years. those microscopic droplets suspended in the air. Under the influence of the wind and the cooling of the heights, begin to gather, they grow heavy, until the sky can no longer hold them against the pull of gravity. Every drop that falls to the soil was once something else. It might have been a wave in a distant, restless ocean, the breath of a deep green forest, or a fragment of an ancient glacier locked in ice for 10,000 years. The water you hear pattering against the roof tonight is a traveler, a nomad of the biosphere. It is part of the hydrologic cycle, a closed system of perfect efficiency where nothing is ever truly lost, only transformed. The process begins with the sun's warmth, which we explored in our earlier chapters. As solar energy hits the surface of the seas, it gives the water molecules enough excitement to break free from their liquid bonds. They turn into water vapor, an invisible gas that rises silently into the air. This is evaporation, the planet's way of breathing moisture into the sky. Even plants participate through transpiration, releasing tiny ghosts of water from the pores of their leaves. As this vapor rises, it meets the cooler air of the higher troposphere. Here, the energy fades, and the molecules begin to slow down. They find those tiny seeds of dust or salt we spoke of, and they condense. Millions of these tiny droplets must collide and coalesce, bumping into one another within the turbulent heart of a cloud, to become heavy enough to fall. It takes 1 million cloud droplets to create just one single raindrop. Think of the physics inside a rain cloud. It is a place of constant motion. Updrafts push the small droplets higher, while gravity tries to pull the larger ones down. When the drop finally wins the battle against the rising air, it begins its long descent. A raindrop is not shaped like a tear, as many believe. As it falls through the air, the pressure of the wind flattens its bottom, making it look more like a tiny, translucent hamburger bun. It rushes toward the earth at speeds of up to 20 miles per hour, bringing with it the coolness of the upper atmosphere. There is a profound peace in the sound of rain. It is a white noise that masks the distractions of the world. Biologically, we are wired to feel safe during a gentle rain. For our ancestors, rain meant that predators were likely in hiding, and that the coming days would bring growth and food. That ancient sense of security still lingers in our DNA, making the sound of raindrops on a windowpane one of the most effective lullabies in nature. Consider the different voices of rain. The stratiform rain, which comes from those wide, flat gray clouds, is steady and rhythmic, a long, lingering drizzle that soaks deep into the earth. It is a patient rain, one that encourages reflection and stillness. Then there is the convective rain, the sudden, heavy downpour of a summer afternoon. These drops are larger, more energetic, born from the violent upward surges of heat. They wash the air clean, removing dust and pollutants, leaving behind that earthy, sweet scent we call petrichor. Petrichor is the smell of the earth receiving a gift. It is caused by the release of oils from plants and a compound called geosmin from the soil, triggered by the impact of the raindrops. It is the scent of life being renewed. When the rain reaches the ground, its journey is far from over. Some of it is drank by the thirsty roots of trees, some flows into silver streams and rushing rivers, and some seeps deep into the darkness of underground aquifers. Eventually, all of it finds its way back to the ocean, or back into the air through the warmth of the next morning's sun. It is a circle without an end, a dance that has no final step. The water cycle is the Earth's primary way of moving energy and life. It is the great equalizer. It reminds us that we are all drinking the same water that the dinosaurs drank, that the same molecules have been through the hearts of whales and the petals of ancient flowers. There is a beautiful continuity in this, a sense of being part of a vast, flowing history. As you listen to the imagined rhythm of the rain, let your thoughts become fluid. Let them wash away the stresses of the day, just as a gentle shower washes the dust from the leaves of a tree. You are part of this cycle too. Your body is mostly water, a small vessel holding a bit of the ocean for a short time. The atmosphere is currently working to balance its moisture. Somewhere, a cloud is growing heavy. Somewhere else, the first drop of a storm is hitting a dry stone. The music of the water cycle is playing in 1,000 places at once. The rain does not hurry. It falls when it is time, and it stays as long as it is needed. It is a lesson in patience and surrender. The clouds are thinning now in your mind. The rhythm of the drops is slowing down, becoming a soft, intermittent whisper. The earth is satisfied, the air is clean and cool. Feel the freshness of the air you are breathing. It is rich with the memory of the rain. The world is damp, quiet, and perfectly at rest. The dance continues, but for now, the music is soft. The water is finding its way home, and you are finding yours, in the deep, rhythmic stillness of the night. We have just listened to the peaceful song of the rain, the meditative rhythm of each drop hitting the soil. But sometimes, this tranquility shifts its color, fueled by a massive accumulation of energy deep within the clouds. Inside the towering giants of the sky, billions of ice crystals and water droplets are rubbing against one another, creating an invisible sea of static electricity. It is much like the tiny spark you feel when you touch metal after walking across a carpet, but this time, it is on a scale of miles, at temperatures hotter than the surface of the sun. Lightning is the atmosphere's way of releasing its internal tension. That blinding white light that tears through the darkness for a fraction of a second is nature's purest display of power. And the thunder that follows is the staggering, yet awe-inspiring sound wave created as that immense heat causes the air to expand suddenly. In this journey, we will explore the physics behind this electric dance, and the strange sense of security that can be found within this magnificent chaos. To understand the spark of the sky, we must look into the heart of a cumulonimbus cloud. Inside these vertical titans, there is a violent struggle. Powerful updrafts carry water droplets toward the freezing heights, while downdrafts bring ice pellets, or graupel, back toward the base. As they pass each other, they collide. In these collisions, electrons are stripped away. The lighter ice crystals, moving upward, carry a positive charge to the top of the cloud. The heavier ice pellets, falling downward, carry a negative charge to the bottom. This creates a massive electrical imbalance. The top of the cloud becomes a vast reservoir of positive energy, while the base becomes intensely negative. Because opposites attract, this negative charge at the bottom of the cloud begins to pull at the positive charges on the ground below. It pulls at the tips of trees, the tops of buildings, and even the blades of grass. The tension builds, silent and invisible, until the air, which is normally an insulator, can no longer hold the two apart. Then, the breakdown begins. A step leader, an invisible stream of negative electrons, starts to zigzag down from the cloud in 50-meter jumps. As it nears the ground, a positive streamer reaches up to meet it. When they touch, the circuit is closed. In that microsecond, return stroke of brilliant energy surges back up the path to the cloud. This is what we see as lightning. A single bolt of lightning is less than an inch wide, yet it carries enough energy to light a medium-sized town for a day. It heats the air around it to 50,000 degrees Fahrenheit, 5 times hotter than the sun. This sudden, explosive heating causes the air to expand at supersonic speeds, creating a shockwave. That shockwave is what we hear as thunder. If you are close to the strike, the thunder is a sharp, terrifying crack. But from a distance, as the sound waves bounce off hills, buildings, and different layers of air, it becomes a long, low, rolling rumble. It is a sound that vibrates in your chest, reminder of the sheer scale of the world we live in. Because light travels almost 1,000,000 times faster than sound, we always see the flash before we hear the roar. By counting the seconds between the two, you can measure the distance of the storm, 3 seconds for every kilometer. It is a simple, rhythmic way to participate in the science of the sky. There are many types of this electric ballet. Most lightning, about 80%, stays within the clouds. We see it as sheet lightning, a soft, flickering glow behind the vapor, like a giant lamp being turned on and off in another room. Then there is bead lightning, ribbon lightning, and the rare, mysterious ball lightning, which scientists still struggle to fully explain. Higher up, above the storm clouds, even stranger things are happening. Blue jets and red sprites dance in the upper atmosphere, flickering for only a few milliseconds. They are like ghosts of the storm, reaching toward space while the lightning reaches toward the earth. It is a complete vertical circuit, connecting the ground to the very edge of the void. As you lie in the safety of your room, think about the atmosphere as a giant battery. It is constantly being charged by storms all around the globe. At any given moment, there are about 2,000 thunderstorms happening on Earth. They are essential. Without them, the electrical balance of our planet would fade. Lightning also plays a vital role in life itself. It breaks apart nitrogen molecules in the air, allowing them to combine with oxygen and fall to the ground with the rain as natural fertilizer. The storm that keeps you awake is the same storm that feeds the forests. There is a unique peace to be found in a thunderstorm. The serenophilia, the love of thunder and lightning, comes from the feeling of being small and safe while the universe expresses its raw energy. Behind the noise, there is a profound cleansing. The air feels crisper after a storm because lightning produces ozone, giving the world that sharp, fresh scent of renewal. Imagine the light now, not as something jarring, but as a majestic, silent pulse. See the clouds flickering in the distance, far enough away that the thunder is only a faint, soothing hum. The electricity is dissipating, the tension in the sky is being released. The atmosphere is finding its equilibrium once again. The flashes are becoming less frequent. The rumble is moving further away, drifting over the horizon toward other lands. The static in the air is gone, replaced by a heavy, cool stillness. Your own energy is also settling. Like the ground after a strike, the tension has left your muscles. The air around you is charged with a quiet, revitalized peace. The sky has spoken, its power has been seen and heard, and now, it returns to the silence. The clouds are still there, but they are no longer heavy with fire. They are just shadows moving across the moon. Feel the cool, ozone-rich air fill your lungs. Breathe in the stillness of the aftermath. The world is safe, the balance is restored. The electrical dance is over for tonight. Drift now into that deep, post-storm quiet. The rhythm of the world has returned to a soft, steady pulse. You are part of this magnificent, energetic planet, protected and at peace. We have just imagined how the sky was shaken by that immense electrical energy, how the lightning tore through the darkness with its raw and jagged power. But now, all that noise and intensity gives way to a deep, white silence. As the temperature drops below the freezing point, the water vapor within the clouds begins to transform, skipping the liquid phase entirely and turning directly into ice crystals. This is nature's most magnificent architectural art performed on a microscopic scale. Imagine a world where every single inhabitant is a unique masterpiece. A snowflake begins its life as a tiny speck of dust or a microscopic grain of pollen drifting high in the troposphere. When the air is cold enough, water vapor molecules begin to huddle around this tiny seed, arranging themselves into a rigid, hexagonal lattice. This six-sided symmetry is not an accident, it is a geometric proof of the way water molecules naturally bond together, like a set of tiny, interlocking magnets. As this initial crystal begins to fall, it travels through different layers of the atmosphere, each with its own specific level of humidity and temperature. It is this journey that dictates the snowflake's final form. If the air is very dry, the crystal may remain a simple, elegant hexagonal plate. But if it passes through a patch of moist air, the corners of the hexagon begin to sprout branches, and those branches sprout smaller needles, creating the classic, intricate, stellar dendrite that we recognize as the soul of winter. Because no two snowflakes follow the exact same path from the cloud to the ground, encountering the same microscopic variations in wind and moisture, no two are ever truly alike. Each one is a silent diary of its own descent, carrying a unique story written in ice. Think of the physics of a snowfall. Unlike rain, which strikes the earth with a rhythmic patter, snow arrives with a profound, muffling stillness. This is because snow is an incredible acoustic insulator. The complex shapes of the snowflakes trap air between them, creating millions of tiny pockets that absorb sound waves instead of reflecting them. When a fresh blanket of snow covers the landscape, it doesn't just look quiet, it literally creates a world of silence. It is the atmosphere's way of inviting the world to slow down, to breathe, and to rest. There is a hidden warmth within this cold white world. Snow is an exceptional thermal insulator. Just as it traps sound, it also traps heat. A thick layer of snow acts like a heavy, white down comforter for the earth. Beneath the snow, the ground remains much warmer than the freezing air above. This subniveum space is where life survives the winter. Small creatures, plants, and seeds are kept safe from the biting winds, tucked away in a quiet, protected realm beneath the crystals. Consider the different textures of this frozen gift. There is the powder, light and dry, formed in very cold air where the crystals remain individual and airy. Then there is the wet snow, where the temperature is near freezing, causing the edges of the flakes to melt slightly and stick together into large, heavy clumps. Each type changes the way the world sounds and feels, from the crisp, satisfying crunch underfoot to the soft, heavy silence of a blizzard. As you settle deeper into your rest, visualize the millions of crystals falling right now in the quiet corners of the world. They are not falling in a hurry. Because of their intricate shapes and low density, snowflakes have a very slow terminal velocity. They drift, they tumble, they dance on the lightest breath of air. It can take hours for a single flake to reach the ground from its parent cloud. It is a journey of ultimate patience. Think of the high mountains, where the snow accumulates in layers over centuries, eventually turning into the blue ice of glaciers. Even there, in the most frozen places, there is movement. The snow is a reservoir of future life. It is water held in a temporary, beautiful solid state, waiting for the sun of spring to set it free once again. The atmosphere uses snow to balance the planet's temperature in another way. The albedo effect. A fresh field of snow is the most reflective surface on Earth. It acts like a giant mirror, bouncing up to 90% of the sun's energy back into space. This helps keep the polar regions cold and maintains the delicate equilibrium of our climate. It is a silent, white shield protecting the Earth from overheating. Imagine the air inside your room becoming as still as a snow-covered forest. Feel the heaviness of your limbs, like the heavy branches of a pine tree laden with white powder. There is no wind here, no electricity, no thunder. Just the slow, steady, and inevitable descent of the crystals. Every flake is a lesson in precision and grace. Even in the freezing cold, nature creates beauty. Even in the darkness of a winter night, there is a light that seems to come from the snow itself, reflecting the faint glow of the stars. The world is being covered, layer by layer. The imperfections of the ground are being smoothed away, replaced by a soft, undulating landscape of white. The sharp edges of the world are rounding off, becoming gentle and inviting. Your thoughts, too, can become like these crystals. Simple, geometric, and calm. Let them drift down through the quiet layers of your mind. Let them settle softly, one by one, until everything is covered in a peaceful, insulating silence. The atmosphere is holding its breath. The clouds are tired of their heavy burden and are letting it go with a graceful surrender. The journey of the snowflake is almost complete. It has found its place on the earth, and you are finding yours in this stillness. The air is cold, but you are warm. The world is silent, but it is alive with the hidden pulse of the winter. Everything is balanced. Everything is quiet. The crystals continue to fall, silently, endlessly, weaving a blanket of rest for the entire world. We have just imagined that white and silent blanket covering the earth, the crystalline piece of snowflakes, each a miniature work of art drifting in a world without sound. But the atmosphere is not always a quiet harbor, it is also a vast and restless reservoir of energy. Sometimes, this energy becomes trapped within a narrow column, connecting the very heart of the sky to the soil of the earth. Tornadoes are nature's most concentrated display of rotation, a vertical axis of power that is both terrifying and majestic. The story of a tornado does not begin with a roar, but with a collision. Imagine a vast, flat landscape, perhaps the Great Plains of North America. From the south, warm, moist air flows up from the tropical oceans, thick with humidity and potential energy. At the same time, from the north or the west, a dry, cold tongue of air slides over the top of it. This creates an unstable sandwich of atmosphere, where the warm air is desperate to rise, but is momentarily capped by the heavier air above. As the sun heats the ground, the pressure builds. Eventually, the warm air finds a hole in the cap and erupts upward, creating a massive, towering thunderstorm known as a supercell. These are not ordinary storms. They are organized giants that have learned how to breathe and spin. Inside this giant, the wind is shifting. Near the ground, the wind might be blowing from the east, but higher up, it is screaming from the west. This difference in wind speed and direction with height is called wind shear. It creates an invisible, horizontal cylinder of rolling air, like a carpet being rolled across the sky. But a tornado needs to stand up. The powerful updraft of the supercell, that invisible elevator of warm air we discussed in earlier chapters, catches this rolling cylinder and tilts it. One end is pulled toward the stars, and the other is anchored toward the earth. Now, the storm itself is rotating, a slow, massive movement called a mesocyclone. Within this rotating heart, the spinning becomes tighter, faster. Like an ice skater pulling their arms inward to spin with more intensity, the air is drawn toward the center of the low pressure. The radius shrinks, and the velocity explodes. This is the law of conservation of angular momentum, the same physics that governs the galaxies and the atoms, applied to a column of air. A visible funnel begins to descend. It is not made of wind, for wind is invisible. The funnel we see is actually a cloud of water droplets, condensed out of the air because the pressure inside the vortex is so incredibly low. It is a vacuum cleaner of the sky, cooling the air so rapidly that the moisture turns into mist. When it touches the ground, it gathers the dust and the debris of the world, taking on the color of the earth it treads upon. Inside the very center of a tornado, in that narrow core just a few hundred yards wide, there is a strange and terrifying mystery. Some scientists believe there is a downdraft of clear air in the very middle, a moment of eerie calm surrounded by walls of wind moving at 300 miles per hour. It is a place where the laws of the everyday world seem to bend. Tornadoes are measured by the enhanced Fujita scale, from a gentle EF0 that might only rustle the shingles of a roof, to the monstrous EF5, which can strip the asphalt from a road and turn trees into toothpicks. Yet, for all their violence, they are incredibly short-lived. Most tornadoes last only a few minutes, traveling a few miles before the energy is spent, and the balance of the atmosphere is restored. Think of the energy being released. A large tornado contains the power of several nuclear bombs, yet it is all contained within a single, elegant, twisting thread of vapor. It is the atmosphere's way of dealing with extreme instability, a quick, violent correction to a deep imbalance between the heat of the surface and the cold of the heights. As you rest in your quiet space, recognize that these giants are rare. Most of the time, the atmosphere manages its energy with much more subtlety, with the gentle breezes and the slow clouds we have already met. The tornado is the exception. The rare moment when the mathematics of the sky reaches a fever pitch. Visualize the storm beginning to fade. The cold air from the back of the storm eventually wraps around the funnel, cutting off its supply of warm, moist air. The occlusion begins. The funnel thins out, looking like a long, ropey thread in the sky. It twists, it kinks, and then, it simply vanishes. The energy has been dissipated. The tension has been broken. The sky remains dark for a time, but the rotation has stopped. The air is remarkably still after such an event. There is a heavy, expectant silence. The pressure begins to rise again, stabilizing the world. Even in the most powerful storms, there is a structure, a logic, and a beauty. It is a reminder that we live on a dynamic planet, a world that is constantly moving, shifting, and breathing. We are safe because we understand these patterns, because we can see them coming, and because we know they must pass. Feel the absolute stillness of your own environment now. Your breath is steady, and there is no rotation here, only the soft, linear flow of the night air. The storms of the world are far away, and the sky above you is becoming clear. The clouds of the supercell are breaking apart. The stars are beginning to peek through the gaps in the vapor. The ground is cooling, and the heat that fueled the giant has radiated away into the coldness of space. Everything is returning to a state of rest. The atmosphere is calm, the pressure is even, and the great engine of the weather has slowed to a quiet hum. You are anchored, you are safe, and the world is stable once more. The heart of the storm has stopped beating. And the night has claimed the silence. Drift now, away from the power and the motion, into the vast, unmoving peace of the stars. We have just looked into the heart of that narrow, furious tornado that appears suddenly in the middle of a plain and vanishes within minutes. Now, let us turn our gaze toward the vast, endless oceans, and the atmosphere's largest and most disciplined giants. Hurricanes, unlike tornadoes, are in no hurry. They are massive weather machines that brew for days over warm tropical waters, drawing their strength from the very rotation of the earth itself. The birth of a hurricane is the most magnificent way the ocean returns the heat it has stolen from the sun back into the atmosphere. It is a process of profound transformation, where warm water becomes wind, and wind becomes a wall of energy thousands of miles wide. Imagine thousands of square miles of rain bands swirling in a perfect, rhythmic spiral, and at the center, that eerie, impossibly silent eye. To build such a giant, the atmosphere requires a specific set of ingredients. First, it needs the ocean to be warm, at least 80 degrees Fahrenheit, reaching deep down below the surface. This warm water is the fuel, the high-octane energy source for the storm. As the sun beats down on the tropical seas, it causes massive amounts of water to evaporate, rising into the air as warm, moist vapor. As this moisture rises, it cools and condenses, forming towering clouds. But remember our earlier discussion on latent heat. When water vapor turns back into liquid droplets, it releases the energy it took from the sun back into the surrounding air. This heat warms the air even further, causing it to rise even faster, which in turn pulls more moist air up from the ocean surface. A feedback loop is born. A self-sustaining engine of thermodynamics that begins to breathe on its own. But heat alone is not enough to create a hurricane. It needs the Earth's spin. Close to the equator, within 5 degrees of latitude, the Coriolis effect is too weak to get the air spinning. But further out, the rotation of our planet begins to nudge these rising columns of air. They start to swirl. The low pressure at the center begins to tighten. And the winds begin to organize into a circular pattern. What was once a disorganized cluster of thunderstorms becomes a tropical depression, then a tropical storm, and finally, when the winds reach 74 miles per hour, it is crowned a hurricane. The anatomy of a hurricane is a masterpiece of atmospheric engineering. On the outside, long, curved bands of rain and wind reach out like the arms of a galaxy, moving inward. The wind speed increases steadily, until you reach the eye wall. This is the most violent part of the storm, a ring of towering clouds where the winds are at their peak, and the rain is a solid wall of gray. And then, in the very center, there is the eye. It is one of the great paradoxes of nature. Inside this circle, which can be 20 to 40 miles wide, the winds go calm. The clouds break away. And you can often see the blue sky or the stars above. While the most powerful winds on the planet are raging just a few miles away in the eye wall, the center is a place of absolute, ghostly peace. Birds have been known to fly within the eye, trapped in a sanctuary of stillness moving across the sea. The scale of a hurricane's energy is almost beyond comprehension. An average hurricane produces as much energy in a single day as the entire human race uses in a year. It is a heat pump of planetary proportions. Its purpose, in the grand logic of the Earth, is to move excess heat away from the tropics and toward the poles. It is a cooling mechanism for the oceans, preventing the tropical waters from becoming stagnant and overheated. A hurricane is a creature of the sea. As soon as it wanders over land, it loses its fuel source. The friction of the ground slows its winds, and the lack of warm water vapor causes its central engine to sputter and fade. It begins to unwind, spreading its moisture across the land as heavy rain, returning the water to the soil, completing the cycle we explored in the Song of the Rain. As you lie still, think of the slow, majestic rotation of these storms. They are not erratic like the tornado. They are predictable, following the deep currents of the atmosphere like ships on a voyage. They are a reminder of the sheer volume of our oceans and the depth of the energy they hold. Visualize the ocean now, far away from any land. The waves are being whipped into white foam by the circular winds. The air is thick with salt and mist. But as we move higher, above the storm, there is a vast, silent canopy of white clouds, spiraling slowly against the darkness of space. The hurricane is a sign that the Earth is a living system. It is a system that knows how to balance itself, how to breathe, and how to move. Even in its destruction, there is a renewal. It brings nutrients from the deep ocean to the surface, and it carries life-giving water to distant parched lands. Feel the slow, rhythmic expansion and contraction of your own chest. Like the hurricane, you are a system of energy. But your energy is contained, calm, and steady. There is no storm here, only the peaceful, lingering warmth of a world that has found its center. The great vortices of the ocean are far across the horizon. Their roars are muffled by thousands of miles of quiet air. The pressure in your room is stable, the air is soft, and the movement of the world is a gentle, swaying cradle. The clouds are drifting, the winds are equalizing, and the heat of the day has been carried away. The atmosphere is finding its rest, and you are finding yours. Everything is in its place, the oceans are quiet, and the sky is a vast, protective dome over your sleep. Drift now into the deep, blue silence of the calm after the storm. The journey continues, but for tonight, the giant is at peace. We have just imagined the heavy, slow breath of the oceans, those majestic hurricane wheels that churn for weeks over the warm tropical waters. But now, let us lift our gaze entirely from the surface of the earth, rising far above the highest clouds, to the very edges of the atmosphere, into those thin and freezing corridors where commercial jets glide like silver needles. The jet streams are the invisible rivers of the sky. They are ribbons of wind thousands of miles long, yet only a few hundred miles wide, wrapping around the globe like a high-speed belt of energy. They are born in the delicate borderlands, where the freezing air of the poles collides with the scorching heat of the equator. In this journey, we will explore how these high-altitude titans shorten flight times, how they steer storms like toys across the map, and how they transform into the elegant, sweeping, raspy waves, by the very rotation of our world. Even within this high-speed flow, there is a strange mathematical order, a fluid peace that dictates the rhythm of our weather. Imagine yourself ascending through the layers of the atmosphere. Past the cumulus clouds, past the anvil tops of thunderstorms, until the air becomes thin and the sky turns a darker shade of indigo. Here, at the boundary between the troposphere and the stratosphere, lies the tropopause. This is the home of the jet stream. It is a place where the wind does not just blow, it screams, reaching speeds of over 200 miles per hour. Yet, because the air is so thin, there is no rustling of leaves, no sound of a storm, only a silent, relentless rush of kinetic energy. The physics of these rivers is a story of pressure and temperature gradients. Think of the planet as a giant heat engine. The tropics are always receiving a surplus of solar energy, while the poles are constantly losing it to space. Nature, as we have learned, hates an imbalance. Warm air from the equator tries to move toward the poles, while cold air tries to slide toward the equator. But because the Earth is spinning, the Coriolis effect deflects this movement. Instead of moving directly north or south, the air is bent into a powerful, westerly flow. This is the polar jet stream. It sits like a guardian at the edge of the Arctic, keeping the freezing air trapped in the north. Further south, we find the subtropical jet, another river of air that flows at even higher altitudes, driven by the same global desire for equilibrium. These rivers do not flow in straight lines. They meander, like a great Mississippi River in the sky. These giant loops are known as raspy waves. When a loop dips far to the south, it brings a trough of cold, polar air down to the temperate zones, creating a cold snap. When it ridges high to the north, it brings warm, tropical air with it, giving us unseasonably warm days. The jet stream is the master puppeteer of our seasons. Every heatwave and every blizzard is a result of where these invisible rivers are flowing at any given moment. Pilots understand the power of these rivers intimately. When flying from west to east, they seek out the heart of the jet stream, hitching a ride on its back to save time and fuel. But when flying against it, they must dive below or climb above it to avoid its punishing headwind. It is a reminder that even in our modern world, we are still subject to the vast, fluid dynamics of the planet. The jet stream is also the cradle of our storms. Where the wind speeds are the highest, jet streak occurs. This creates areas of divergence and convergence in the upper atmosphere. Like a giant vacuum, the jet stream pulls air up from the surface of the Earth, creating the low-pressure systems that bring us rain and wind. Without these high-altitude rivers, the weather on the ground would be stagnant, unchanging, and lifeless. Think of the sheer beauty of this invisible architecture. If we could see the air, the jet streams would look like glowing, translucent ribbons of sapphire and silver, pulsating with the energy of the sun and the momentum of the Earth's spin. They are the nerves of the atmosphere, communicating changes in temperature and pressure across thousands of miles in a matter of days. As you lie in your bed, visualize the wind 10 miles above your head. It is moving at incredible speeds, yet here, on the ground, there is only a soft, night silence. We are protected by the density of the air around us. The atmosphere acts as a buffer, absorbing the chaotic energy of the heights and turning it into the gentle cycles we experience on the surface. The jet stream is currently shifting. It is undulating in a slow, rhythmic dance that has been going on since the atmosphere first formed. It is part of the global circulation, a system that ensures that no part of the Earth is ever truly isolated. The air that is rushing over the Himalayas tonight might be the same air that brings a breeze to your window next week. There is a deep comfort in the continuity of this flow. It is a reminder that the world is always in motion. Even when we are still, the planet is breathing, circulating, and maintaining itself. You are part of this massive, rotating system, tucked away in a quiet pocket of stability. The high-altitude winds are clearing the sky for the morning. They are sweeping away the remnants of the day's clouds, leaving behind a crisp, cold void where the stars can shine their brightest. Let your mind rise to meet these rivers. Feel the sensation of being carried by a current that is larger than any human concern. A current that follows the laws of physics with perfect, unyielding grace. The pressure is dropping in the heights, but it is rising in your heart, bringing a sense of lightness and expansion. You are drifting on a raspy wave of your own making. A gentle, slow curve toward the horizon of sleep. The rivers of the sky are flowing. The earth is spinning. And you are safe within the layers of the air. Everything is connected, from the heat of the sun to the cold of the jet stream, to the steady rhythm of your own heart. The invisible Nihurler are guarding the world, guiding the seasons, and ensuring the balance of the night. Drift now, into the high, clear stillness of the upper atmosphere, where the wind is a song and the silence is a blanket. We have just imagined ourselves gliding upon those crystal-clear, ice-cold, and lightning-fast jet streams at the very edge of the sky. But now, let us turn our gaze from that rarefied air down to the warmest and most solid texture of our planet, to the very heart of the deserts. Dust storms are the most intense and magnificent way the atmosphere embraces the earth itself. These massive walls of dust, known as habubs, can reach miles into the sky, painting the horizon in shades of deep crimson and trapping the world in a sudden, gritty silence. The birth of a dust storm is a story of gravity and thermal contrast. It often begins with a collapsing thunderstorm far across the arid plains. As the rain falls through dry air, it evaporates before hitting the ground, a phenomenon known as virga. This evaporation cools the air rapidly, making it dense and heavy. Like a giant invisible hammer, this cold air crashes down toward the desert floor. When it hits the scorching sand, it has nowhere to go but outward. It creates a powerful, gusting, outflow boundary that acts like a plow. Imagine millions of tons of ancient sand and microscopic silt being lifted into the air. The habab, an Arabic word meaning blasting or drifting, is a solid wall of earth moving across the landscape. Inside this wall, the sun is blotted out, and the world turns into a monochromatic dream of amber and gold. The physics of this movement is called saltation, where larger grains of sand bounce along the surface, striking smaller particles and launching them high into the turbulent air. As you lie still, think of these dust clouds not as pollution, but as the Earth's own courier system. These storms are the great bridges of life. The dust lifted from the Sahara Desert in Africa does not simply fall back to the dunes. It rises high into the atmosphere, caught in the very trade winds and jet streams we discussed before, and begins a journey across the Atlantic Ocean. This mineral-rich dust, millions of years old, is the secret lifeblood of the Amazon rainforest. Thousands of miles away from its home, the Saharan dust falls with the rain, providing essential phosphorus and minerals to the lush, green canopy of South America. Without the dry, desolate breath of the desert, the richest forests on Earth would struggle to survive. It is a profound demonstration of the Earth's interconnectedness. The desert feeds the jungle, and the wind is the messenger. There is a unique sensory experience within a dust storm. The air becomes thick and heavy, carrying the scent of dry earth and ancient minerals. The sound is a low, continuous hiss, the collective friction of billions of grains of sand striking one another. It is a sound that smooths the edges of the world, burying the noise of civilization under a layer of elemental grit. Habubs are most common in the summer months, when the heat of the day creates the most violent thunderstorms. They move with a surprising speed, rolling over cities and dunes alike, leaving behind a fine, powdery veil on every surface. To look at a desert after a storm is to see a landscape that has been rearranged. The dunes have shifted, the paths have vanished, and the desert has reclaimed its mystery. But even in this chaos, there is a meditative quality. The dust storm forces the world to stop. Visibility drops to nothing, and for a few hours, the only reality is the wind and the earth. It is a time for introspection, for waiting, and for acknowledging the power of the planet's surface. Think of the global dust cycle. Every year, nearly 2 billion tons of dust are moved through the atmosphere. It is not just about fertilizing forests. The dust also falls into the oceans, providing iron to the phytoplankton, the microscopic plants that produce half of the oxygen we breathe. The desert, in its parched silence, is a primary driver of the world's oxygen supply. It is a paradoxical beauty, where the most lifeless places on Earth support the most vibrant. As you rest, imagine the air in your room becoming as still as the center of a desert plateau. The dust of the world is settling. Every speck of dust in the sunlight is a tiny fragment of a mountain, a piece of a shell, or a grain of a star. You are surrounded by the history of the earth. The storm is receding now. The heavy, orange clouds are drifting away, and the first rays of the sun are beginning to pierce through the remaining haze. The sky is a pale, dusty blue, and the air is remarkably calm. The heat of the day is being absorbed by the sand once more. The desert is a teacher of resilience. It shows us how to endure the storm and how to find beauty in the aftermath. The world is clean again, the minerals have been delivered, and the balance has been shifted just enough to keep the cycle moving. Feel the stability of the ground beneath you. It is solid, ancient, and unmoving. The winds have passed, and the dust has found its new home. You are breathing the air of a planet that is constantly renewing itself. The desert's breath is now a quiet, lingering memory in the cool of the night. Everything is resting. The dunes are silent, the wind is a whisper, and the sky is clear. Drift now into the warm, golden stillness of the desert night. The minerals of the earth and the energy of the sky are in perfect harmony. The secret of the desert is revealed in the silence that follows the storm. And that silence is now yours. We have just imagined that crimson and heavy breath of the desert, those millions of tons of sand crossing the sky like mineral bridges to feed distant continents. But now, let us welcome the clearest moment that follows the storm, those magical seconds when light is purified within the falling droplets of water. Rainbows are the most elegant mathematical equations the atmosphere presents to us. Every single raindrop suspended in the air is, in fact, a miniature prism. When sunlight enters this drop, it slows down, it bends, it reflects off the back wall of the sphere, and as it exits, it fans out into a spectrum of pure color. The story of the rainbow is a story of geometry and devotion. It is a celebration of the relationship between the sun, the rain, and your own eyes. To see a rainbow, the sun must be behind you, low in the sky. And the rain must be in front of you. You are the vertex of a grand celestial angle, the central point of a masterpiece that exists only because you are there to witness it. Imagine a single ray of white light, traveling at the speed of causality through the vacuum of space and the layers of our atmosphere. It hits a falling raindrop, a perfect liquid orb. As it crosses the boundary from air to water, the light changes speed. This change in speed causes it to bend, a process we call refraction. But white light is a choir of many voices, and each color within that light bends at a slightly different angle. Red light, with its longer wavelength, bends the least. Violet light, with its short, energetic wavelength, bends the most. The light hits the back of the raindrop. Instead of passing through, it reflects, turning back toward you. As it exits the drop and re-enters the air, it refracts one more time, spreading the colors even further. What reaches your eyes is a fan of color, but because there are billions of drops, and each one is sending its specific color back at a very specific angle, they join together to form a solid arc. The mathematics of this arc is precise. A primary rainbow always appears at an angle of 42 degrees from the shadow of your head. This is why a rainbow is not a thing that exists at a specific location in space. It is an optical phenomenon, a distance-less ghost. If you move, the rainbow moves with you. If your friend stands a mile away, they are seeing a different set of drops reflecting a different rainbow. It is a personal gift from the atmosphere to the observer. As you lie still, think about the order of the colors. Red on the outside, followed by orange, yellow, green, blue, indigo, and finally, the deep, quiet violet on the inside. This sequence is unchangeable, a fundamental constant of our world's physics. It is the signature of the sun, decoded by the water. Sometimes, when the conditions are just right, you might see a second, fainter arc above the first. This is the double rainbow. It occurs when the light reflects twice inside the raindrop instead of once. Because of this extra reflection, the colors are reversed. Red is on the inside, and violet is on the outside. Between the two arcs, the sky often looks darker. This is Alexander's dark band, a region where the light is being redirected away from your eyes. It is a shadow of the spectrum itself. Consider the moonbow, the rare and ghostly cousin of the rainbow. It is created by the light of a full moon reflecting off nighttime rain or the mist of a waterfall. To our eyes, it often looks white or silver because our vision is less sensitive to color in the dark. But the colors are there, hidden in the pale light, a secret spectrum for the night. The rainbow is a bridge between the storm and the calm. It marks the moment when the atmosphere is washing itself clean. The heavy, opaque dust we discussed in the desert has been pulled to the ground by the rain, leaving the air exceptionally transparent. The light can travel further, clearer, and more vibrantly than at any other time. There is a deep peace in this geometry. It reminds us that even in the chaos of a thunderstorm, there is a hidden symmetry. The water that was once a raging flood or a drenching downpour is now a lens for beauty. The light that was once a blinding flash of lightning is now a soft, comforting bow. Visualize the moisture in the air right now. Even if it is not raining, the potential for a rainbow is always there. Every molecule of water carries the blueprint for this spectrum. It only waits for the right touch of light to reveal its inner colors. Your mind, too, is like that water. It can be turbulent, it can be heavy, but it can also be a prism for clarity. Let the light of your awareness pass through the thoughts of your day. Watch them bend, watch them separate, and see them for what they are, simple, beautiful reflections of experience. The colors are fading now, as the sun in your mind sinks lower toward the horizon. The arc is stretching taller, becoming more ethereal, until it blends back into the deepening blue of the twilight. The mathematics remains, even when the colors are gone. The laws of the universe are still in place, silent and steady. The pressure is perfect, the temperature is cooling, and the air is soft. You are at the center of your own circle of peace. The 42-degree angle of rest. No more storms, no more dust. Only the lingering memory of the spectrum, and the quiet promise of the night. Feel the bridge of the rainbow leading you toward the stars. It is a path of light, weightless and calm. The atmosphere has finished its show for today. The curtains of the clouds are closing. The water has returned to the earth, and the light has returned to the sun. Everything is balanced. Everything is reflected. Drift now into the indigo and violet edges of the world. Beyond the colors, into the deep, monochromatic stillness of sleep. The rainbow has done its work, the storm is a memory, and the night is a sanctuary. We have just imagined how light is purified within a single raindrop, how the sky is painted with that perfect mathematical arc at 42 degrees. But now, let us strip away all the moisture and the clouds of the lower world. We are rising far beyond the weather, far beyond the jet streams, into the outermost layers of our atmosphere, to the rarefied and electrically charged depths of the ionosphere. The auroras. The northern and southern lights are a silent letter sent from the sun to the earth. Charged particles that have traveled millions of miles across the void strike our planet's magnetic shield, gliding toward the poles, where they collide with gas molecules to ignite the sky in neon shades of green, pink, and violet. This is not merely a light show. It is the visual proof of how our planet protects us from the harsh winds of space. In this journey, we will explore how these cosmic curtains wave, the meditative energy released as atoms are excited, and the deep, cold silence beneath this most magnificent crown of the night. Here, the breath of the earth meets the light of the stars. To understand the aurora, we must look to the sun, the great engine of our solar system. The sun is constantly exhaling a stream of charged particles called the solar wind. Sometimes, this wind becomes a gale, a coronal mass ejection that hurls billions of tons of plasma into space at millions of miles per hour. When this cloud of energy reaches the Earth, it doesn't crash into us. Instead, it encounters the magnetosphere, our planet's invisible, protective magnetic cocoon. Imagine the Earth as a giant bar magnet, with lines of force arching out from the North Pole and curving back into the South Pole. The solar wind hits this shield and is deflected, flowing around the Earth like water around a stone in a stream. But some of these particles find a way in. They are funneled toward the polar regions, spiraling down the magnetic field lines until they slam into the upper atmosphere. This collision happens in the thermosphere, about 60 to 200 miles above your head. When a high-energy electron from the sun hits an oxygen atom in our air, it transfers its energy, exciting the atom. The atom cannot hold this extra energy for long. To return to its calm, stable state, it must release that energy in the form of a photon, a tiny particle of light. If the electron hits an oxygen atom at lower altitudes, the light it emits is a brilliant, ghostly green, the most common color of the aurora. If it hits oxygen much higher up, where the air is incredibly thin, it produces a rare, deep red glow. Nitrogen atoms, on the other hand, contribute shades of blue and purple, painting the edges of the curtains with royal hues. As you lie in the quiet darkness of the world below, visualize these curtains of light. They do not sit still. They ripple, they fold, and they dance. This movement is caused by the ever-changing pressure of the solar wind and the subtle fluctuations in the Earth's magnetic field. It is a fluid dance performed in a vacuum. A silent symphony of subatomic particles. There is a profound peace in the silence of the aurora. Despite the immense energy involved, there is no sound that reaches the human ear. Some travelers in the far north speak of a faint hissing or crackling, like dry leaves in the wind. Scientists believe this might be an electromagnetic effect, a sound that is felt by the nervous system rather than heard by the ears. It is the sound of the planet's shield vibrating. The auroras are more than just beauty. They are a reminder of our connection to the rest of the cosmos. We are not an isolated rock floating in the dark. We are part of a larger, energetic family. The light you see in the aurora began its journey in the nuclear furnace of the sun 8 minutes ago. It has crossed the vastness of the void just to touch the top of our atmosphere. Think of the ionosphere. It is a layer of the sky that is partially ionized by solar radiation. It is because of this layer that we can bounce radio waves around the curve of the Earth, allowing voices to travel across oceans. The aurora is the visible face of this invisible, electric ceiling. It is the crown that the Earth wears as it sleeps. In the far north and the far south, people have watched these lights for millennia. To some, they were the spirits of ancestors dancing. To others, they were bridges to the gods. Today, we know them as physics, but the wonder remains unchanged. The science does not strip away the magic. It only deepens the awe. As you settle into your rest, imagine the planet below you. You are tucked away in the dense, warm layers of the troposphere. But above you, the planet is communicating with the stars. The green and purple lights are waving a gentle, rhythmic goodbye to the solar wind. The energy of the sun is being safely neutralized. The magnetosphere is doing its job, standing guard over the life below. You are protected by a shield that reaches out thousands of miles into the dark. You are safe, you are home. Feel the vastness of the night sky. It is not empty, it is full of light and movement. The colors are swirling now, slowing down, fading into a soft, ethereal glow. The atoms are returning to their ground state, becoming calm and quiet once again. The cosmic storm has passed. The magnetic lines are steady. The ionosphere is humming with a faint, peaceful energy. Your own energy is also settling. The excitement of the day is being released, photon by photon, thought by thought. You are returning to your own calm, stable state. The aurora is a beacon of tranquility. A sign that even in the coldness of space, there is warmth and protection. The light is dimming. The stars are becoming more prominent. The crown of the night is resting. Drift now into the deep, neon-tinted silence of the upper world. Between the earth and the stars, in the soft, glowing embrace of the ionosphere. Everything is in balance, the sun is distant, and the night is yours. We have just witnessed the cosmic dance of the auroras, drifting in the rarefied depths of the ionosphere at the very edge of space. But now, let us slowly descend back toward the earth, toward the windows of our homes, the branches of the trees, and that peaceful boundary where the last rays of the day are withdrawn. Twilight is the magical transition when the sky says goodbye to blue and dresses itself in indigo, purple, and finally black. When the sun sinks below the horizon, the light reaches us not directly, but by reflecting off the upper layers of the atmosphere. This is the most romantic and tranquil form of Rayleigh scattering. Imagine the sun as a golden ship sailing below the curve of the earth. Even though it is out of sight, its presence is still felt in the glow of the upper air. This lingering illumination is what we call twilight. A bridge between the world of action and the world of dreams. It is a time when the colors gradually lose their saturation, shadows stretch to their ultimate length, and the world exhales a collective breath, preparing for rest. To understand this transition, we must look at the three distinct stages of twilight defined by the sun's position below the horizon. The first stage is civil twilight. This begins the moment the sun disappears and lasts until it is 6 degrees below the horizon. During this time, there is still enough light to see clearly. The sky is often a vibrant palette of orange, pink, and gold. This is the hour of the belt of Venus, that pinkish glow in the eastern sky, which is actually the Earth's own shadow rising into the atmosphere. It is a reminder that the planet is already turning its back on the light. As the sun sinks further, from 6 to 12 degrees below the horizon, we enter nautical twilight. The horizon becomes less distinct, and the first, brightest stars begin to appear, the celestial navigators that have guided sailors for centuries. The sky turns a deep, velvety blue. This is the blue hour, a favorite of poets and dreamers, where the light has a quality of profound stillness. The air feels heavier, cooler. And the birds begin to find their final resting places for the night. Finally, we reach astronomical twilight. The sun is now 12 to 18 degrees below the horizon. To the casual observer, it looks like night, but for the astronomers, there is still a faint, residual glow in the atmosphere that prevents the deepest darkness. Once the sun passes 18 degrees, true night begins. The physics of these colors is a beautiful filtering process. During the day, the shorter blue wavelengths of light are scattered in all directions, making the sky look blue. But as the sun nears the horizon, the light must travel through much more of the Earth's atmosphere to reach your eyes. The blue light is scattered away entirely, leaving only the longer, warmer wavelengths, the reds, the oranges, and the violets, to paint the clouds. As you lie still, visualize the light retreating upward, like a tide going out. First, the valleys fall into shadow, then the hills, then the tops of the tallest buildings, and finally, only the highest, thin cirrus clouds are left glowing with the sun's memory. This vertical retreat of light is a rhythmic, inevitable process that signals to our biology that it is time to slow down. Our bodies respond to this fading light. The pineal gland, deep within the brain, senses the absence of blue light and begins to release melatonin, the chemical of sleep. Our heart rate slows slightly, our body temperature begins to drop, and our focus shifts from the external world to our internal landscape. Twilight is not just a change in the sky, it is a change in our very being. Think of the crepuscular animals, those creatures that thrive in this half-light. The deer, the rabbits, and the owls. For them, this is the time of greatest activity, a period of transition where the world belongs neither to the day nor the night. But for us, it is an invitation to withdraw. The air is becoming crisp. The heat that was absorbed by the soil during the day is now radiating back into space. This is radiational cooling. You can feel the freshness of the night air beginning to settle in the low places. The atmosphere is becoming stable, the winds of the afternoon are dying down, and the turbulence of the heat is being replaced by a calm, stratified stillness. Imagine the sky now, as it moves into the deep indigo of the late nautical twilight. The last sliver of orange on the western horizon is a thin, glowing thread. It is being pulled away, disappearing into the darkness. The stars are becoming sharper, more numerous. Venus and Jupiter might be shining brightly, the first sentinels of the evening. There is a sense of great ancientness in this moment. Every living thing that has ever existed on this planet has watched this same fading of the light. It is a shared heritage of rest. The sun will return, the cycle will repeat, but for now, the sun's work is done. Feel the weight of the shadows in your room. They are not scary, they are a soft, protective blanket. They obscure the details of the day, the tasks left unfinished, the things yet to be done. In the twilight, those things lose their sharp edges, they become blurred, distant, and unimportant. The atmosphere is now almost completely dark. Only the faintest, most ethereal light remains at the very top of the sky. The molecules of nitrogen and oxygen are cold and quiet. The high-altitude winds we spoke of are still moving, but down here, everything has reached a state of equilibrium. You are at the threshold. The day is a memory, the night is a reality. The transition is almost complete. Breathe in the cooling air. Let the indigo light fill your mind. It is a color of deep wisdom, of vastness, and of silence. The world has closed its eyes, and you are invited to do the same. The sky has finished its farewell to blue. It is now a canvas of pure, obsidian possibility. The shadows are merging. The horizon has vanished. The earth is now one with the darkness of the universe. Drift now into the final, deepest stage of the twilight. Beyond the last glimmer, into the total, welcoming embrace of the night. Everything is still. Everything is dark. Everything is ready for the final silence. We have just imagined the final withdrawal of the day's light, that sad and peaceful farewell the sky gives to the color blue. But now, the sun has finally descended more than 18 degrees below the horizon. Astronomical twilight has ended, and absolute night has begun. The atmosphere is no longer a carrier of scattered light, it has become a transparent, protective veil that delivers the ancient light of the stars to our eyes. In this deep darkness, even the highest layers of the air fall into a profound stillness. The winds have calmed, the temperature has reached its most balanced point, and the turbulence of the living world has been replaced by the steady rhythm of the cosmos. Imagine the air around you not as a gas, but as a vast, cooling fluid that has finally come to rest. The kinetic energy of the sun's photons is gone. The molecules of nitrogen and oxygen, which were dancing so frantically under the midday heat, have slowed their vibrations. They are close together, stable, and quiet. This is the thermal equilibrium of the night, a state where the earth stops trying to change, and simply is. As you lie in the total darkness of your room, realize that darkness is not merely the absence of light. It is a frequency, a physical state required for the restoration of life. In this darkness, our vision ceases to be our primary sense, and we begin to feel the atmosphere with our skin, with our breath, and with our intuition. The air feels thicker, more protective, like a heavy velvet curtain drawn across the stage of the world. Look up, even through the ceiling of your room, to the stars above. They are trillions of miles away, yet their light is touching you right now. This light has traveled for thousands of years through the vacuum of space, only to meet the resistance of our atmosphere in the last tiny fraction of a second. The atmosphere acts as a gentle lens. It causes the stars to twinkle, a phenomenon called stellar scintillation. This happens because the starlight passes through different pockets of air with slightly different temperatures and densities. It is the atmosphere's way of breathing, making the distant suns appear to pulse with a life of their own. The stars are the guardians of our sleep. They provide a sense of scale that makes our daily worries seem microscopic. In the face of a galaxy, a deadline or a disagreement loses its weight. The atmosphere allows us to see this vastness while keeping us safe from its cold vacuum. It is our thin, fragile, but incredibly strong sanctuary. Think of the night air. In the absence of solar radiation, the chemistry of the atmosphere changes. The ozone layer continues its silent work high above. Near the ground, the air becomes rich with the sense of dampened earth and sleeping flora. Plants have switched from photosynthesis to respiration, taking in oxygen and releasing carbon dioxide in a slow, rhythmic cycle that mimics our own breathing. We are breathing in unison with the forests and the fields. The pressure is now a constant, unmoving weight. It presses gently against you, anchoring you to the bed, anchoring you to the planet. There are no more updrafts, no more thermals, no more storms. The convection of the day has collapsed, and the air has stratified into peaceful layers. Visualize the quietest part of the atmosphere, the mesosphere. It is the coldest place on Earth, 80 miles above the surface. Even there, in the freezing dark, the air is protecting us, incinerating the meteors that try to enter our world, turning them into falling stars, brief streaks of light that mark the boundary of our safety. Every shooting star you see is a testament to the atmosphere's vigilance. As you settle deeper into your pillow, feel your body becoming part of this atmospheric stillness. Your thoughts are like the fading embers of a fire, glowing softly before turning to ash in silence. The noise of your mind is settling, just as the dust settled in the desert, and the moisture settled in the rain. There is no more need for analysis, no more need for knowledge. The physics have done their work, the chemistry is stable, and the geometry is perfect. We have traveled from the birth of a raindrop to the edge of the galaxy. We have seen the power of the wind and the delicacy of a snowflake. And now, we have returned to the source of all peace, the silence of the night. The earth is turning. It carries you through the dark at 1,000 miles per hour, yet you feel nothing but the softness of your sheets. The atmosphere moves with us, a loyal companion that never leaves our side. It is the air that connects us to every human who has ever lived, and every creature that has ever breathed. In this total darkness, you are not alone. You are part of the planetary breath. You are a single, quiet note in a cosmic lullaby. The stars are watching. The air is protecting. The world is sleeping. Let the weight of the night sink into your bones. Let the transparency of the sky clear your mind. There is nothing left to do, nothing left to think. The journey of the air has reached its destination. The stillness is absolute. The darkness is complete. The atmosphere has whispered its last secret for tonight. It is the secret of the void, the secret of the rest, the secret of the return. Close your eyes, and become one with the quiet air. Sleep well.